Hello. So my camera is not quite working today, so we're going to zip through section 1G and 1H, problem solving and optimization. I am telling you what, could be the greatest day ever. Problem solving, hey, we'd love to solve a good problem, but optimization is really opening the idea of calculus. Kind of gives us a reason to keep pushing forward. We love to know maximums and minimums, stuff like that. Hey, in context problems, I've found that you can solve a quadratic at this stage. Life is good, but it's turning the words into the math that cause a little bit of consternation. So I'm going to help you start the homework problems for tonight, and you are welcome to stop this right now and go work on the problems and then come back, or you can certainly use this more as a reference today. All right, number one, two integers differ by 12 and the sum of their squares is 74. All right, so you got to give yourself something. Give yourself a variable that represents something. So I'm going to say x is an integer. Okay, and in mathematics, well, I won't get into that. So if that's one of the integers and the other one, and they differ by 12, that versus saying it's x and y. See, this is two variables. Why not use one variable? And those certainly do that. The sum of the squares. Sum of the squares means you take one, add it, and we know is always an equal sign. That is what we call a quadratic. You need to multiply and solve that bad boy. Fourth one, the product of two consecutive odd numbers is 255. It is not your fault if you do not automatically think of an odd number in general as 2k plus 1, where k is any integer. That is not in your wheelhouse because you don't use it very often, but plug in any value for k, 7, 10, 20, -8. If you plug it in, you multiply it by 2 and add 1, you will end up with an odd number. Okay, so an even number, we just go ahead and say that's always going to be 2k, where k is any integer. So plug in any integer, multiply it by 2, you end up with an even number. All right, so back to the problem, the product of two consecutive odd numbers. Well, if this is one odd number, then consecutive means right next to it, either side. So if I go to this side, the next odd integer, I wouldn't add 1 to it, I'd add 2 to it, so it'd be 2k plus 3. And the one before it, if I subtract 2, I end up with this. So this is where the mathematics of doing this over and over again, you start to see the little tricks. The product of two consecutive, well, that means I can take this one and this one, multiply them, and set it equal to 255. That's going to work, trust me. Now, I'm going to pick this one and this one. Now, there's a reason behind it, and if you've multiplied binomials out a couple million times like I have, I know that that's going to be a little simpler. So I'm just going to write 2k minus 1, 2k plus 1 equals 255. But I'm also going to show you that 2k plus 1 times 2k plus 3 equals 255. Now we may not get the same k value, but when we plug them back in, we will get the same two consecutive odd numbers. So this is an or. You can do it that way or that way. I claim the one in red would be a little simpler. Multiply it out and see if you like it. All right, the length of a rectangle is 4 centimeters longer than its width. The rectangle has area of 26. To me, I believe that you can do this problem. If you have questions about this, feel free to ask, or hey, Mr. Sayers, can you do number 5 for us? I certainly will. Here's the secret. Draw a rectangle. Good luck. All right, moving on. Now we're getting into some interpretation. Now I've done this problem a couple hundred times. Actually, we cut it out and we make these boxes, and it really helps people see. First of all, it is asking for, well, first you got to understand what you're doing here is you're folding these up. So at the end of the day, you're left with a box. That looks like that. So you're folding those sides up and you have that. So remember, volume is equal to length times width times height. All right, it's asking for the original dimensions of this square. So we already know that from here to here is x, okay? So we know, and we know this to here is x. Sorry, that's coming out weird. All right, so the volume is equal to 80. Well, the number one mistake here is, what is that length? Is it x? Is it x minus 3? Or is it x minus 6? I wish I could just leave it like that, but I'm going to go ahead and just remind you. Volume is equal to length times width times height. If we fold this thing up, it is telling us that length is 3. Tell you the volume, plug it in, multiply it out, it's a quadratic. Once you get to this stage, you should notice that it's a quadratic and have the sense of relief that you have the quadratic formula, which solves all quadratics. All right. 8, is it possible to bend a 20 centimeter length of wire into the shape of a rectangle? So I love this problem because it uses a word that allows us to maybe do less work. Possible. It does not ask us what the dimensions of the rectangle have to be. They're just saying, hey, can you? So this is kind of like saying, will it have solutions? You know, so that's that whole idea of maybe you make an association to b squared minus 4ac is greater than 0. I doubt people are making that. It's not like, oh, if you're not, I'm so disappointed. It's more like, possible. Is there solutions? We know there's solutions if that discriminant inside the quadratic formula is equal to or greater than 0. So draw a picture, pick a length. My challenge to you is, if the whole thing is 20, what is that side? I'll give you a hint. This side is also x. Area is equal to length times width. 30 is equal to x times something. Find this in terms of x. You know the whole thing is 20. Go for it. You're going to get a quadratic. And you're going to set that quadratic equal to 0. If you solve the quadratic, you will actually find that length exactly that makes it happen. Or you can do a shortcut and go with the discriminant. If it's greater than 0, you could answer, yeah, it's possible. I'm just trying to hopefully get you to the point where you can make decisions of what you need to do to answer the question. If you go ahead and get x equals, that's awesome, but not necessary. Two C's. I'll just do it scribbly. So I got it right. All right. All right. Come on, people. easy problem to like, oh, we don't need to do this because there's so much writing. This is the golden ratio. This is why people study mathematics. This is where the artists and the physicists and the naturalists and the mathematicians are all come together and just high five because everybody's shaking their head. Mother Nature is just rocking the math. All right. So you have a rectangle ABCD. We're going to decide where this line goes. So it works out perfect here. Parallel to short side. The smaller rectangle BCXY, this little rectangle, is similar to the original rectangle. So that can be a challenge to interpret. Let me see if I've done this right. Woo, 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 woo. So there's the big one and there's the small one. If we rotate this, that's what they mean by similar. Do you remember that class called geometry? We did a lot of similar figures. So we'd say this side to this side is equal to this side over this side. So that's kind of the idea behind similar. All right, let's try and see if we can figure this out. They give you a hint. Let A be equal to X. So this whole thing is X. And then this length here is 1. Why that's important is let's translate that to our blue and red. So this is 1 and this is X. And notice that I rotated that red. So this is 1. And this short side, the whole thing is X. This is 1. So this is going to be X minus 1. So this length here is X minus 1. And you're listening to me going, stop. Work it out for yourself. Justify, if I call this X and this 1, how I take that smaller rectangle, rotate it, and that 1 and that X minus 1. Because then life is good. All right, if they're similar, then X over 1 should equal, so this length over this length should equal this length over this length. Mr. Sayers, that's not how my geometry teachers had it. It means they had to do this one over this one equals this one over this one. You get the same thing. Okay, cross multiply. You get x squared minus x equal to 1. X squared minus x minus 1 equals 0. Use quadratic formula. No calculator. Look at your answer. Sure looks like a negative b plus or minus square root something over 2a. You know what I mean? You know what I mean? Give it a shot. Could not go on without talking a little bit about what we call the golden ratio. Everything in here has the golden ratio in it. This one's a little bit pushing it, the Mona Lisa. I think they forced it a little bit, but it's amazing photo. It's really small. I'm not flexing a little bit. Go to the Louvre, check it out. It's amazing. This is called the Mandelbrot set. And the Mandelbrot set is a graph on complex number. So this is just a point, and we decide to color it blue, red, yellow, black, depending on a little rule. It is unbelievable. But what's cool is if you pick anything right there and you grab any point, which is one complex number, and you put it through the paces, the amount of times it takes to land on itself is a Fibonacci number, and a Fibonacci number is part of the golden ratio. It's just no way. They are not related. Oh yeah, they are one and the same. I pulled this picture up because your face is cut up into this golden ratio. It's about 1.618. That's what 1 square root of 5 over 2 is about. And so if you have the perfect ratios, then you have this length to this length. This is what plastic surgeons do. They take a picture and say, oh boy, if I were to do this for 1 centimeter. That is a great thing. I am not going to make any kind of judgment call, but you are beautiful as you are. At some point in your life, you're going to realize it is all about personality and less about social media and what's supposed to be good and what's supposed to be bad. So just thought I'd let you know. Oh, this is amazing. It's probably one of the coolest. Oh, I use green on a green. So the number of leaves that come out as it spirals up is the perfect amount of shade and sunlight for the rest of the plant below it. And it follows what we call a Fibonacci spiral. Unbelievable. Sorry. All right, number 12. Okay, we're up to 15 minutes here. So number 12 is a great problem. The first one is find the equation of the graph. And what you're using is the point -3, 0 and 3, 0. Those are the roots. And you're using the y-intercept of 0, 8. We had a whole assignment on can you write the equation if I gave you the 2 roots and another point. So I'm thinking part A you can do. Part B is a little bit weird to understand. Here's your car, the back of the truck, and you're flying, and you can't see the tires or anything, and you're coming up to the bridge or the tunnel, and you're like, woohoo, can I squeeze in? Oh, I don't know, can I? It's like those crazy movies where the car is scraping along the side. So the question is, will I hit? What a weird question. It's like you want the coordinates of that point on this quadratic. But what's the x value? Well, the x value is from here over. If you have a 4, this whole thing is 4, can you tell me what that width would be? Which means it would be that x value, which means we could plug it into this equation and figure out the y coordinate. We might want to compare the y coordinate with the y coordinate of the truck or the height of the truck. I hope that's enough. Hey, the next section, I believe is H. It's actually a little simpler. A, find vertex. Find x coordinate of the vertex. And B, find the y coordinate of the vertex. Just don't do it and get the answer and say, hey, don't I know? Get it, stop, and try to make sure that you can put this in a sentence. Your x, there's no x's in the real world. The x stand for something, okay? And x is the number of refrigerators in this case, and the y in this case is the amount of money you're going to make, okay? Believe it or not, the more refrigerators you sell, not necessarily the more money you make. There is an optimal number of refrigerators. Isn't that a cool problem? Yep, no charge for that. When we say show, they're saying this is the answer. That's the answer. That's what you should get. So when you find the area of this, area equals length times width, area equals x times, you're going to have to figure out what that is. Okay, remember we have total 200. You should get that. So we love show that problems because they're saying, hey, maybe you struggle, you didn't quite get this, but now use that to answer this. So find vertex. Maximum. Maximum happen at the top or bottom of parabolas. Sorry, max and mins happen at the top and bottom. Yeah. All right, I'm going to help you out with a little bit. Draw a picture. There is a water drain. Don't know what that is. you have a rectangular paddock. Okay, I'm going to give you the tough part. I'm going to make this X. Oh, you know what this is then. So the question is, what is that? And then you need to find the area formula and then find the vertex. Answer is interesting. I'll bet you guys could guess what it is, but I think most of you would guess not quite right. It's a pretty cool problem. Number 5 is messed up. I just slow down, relax a little bit. When they say, why is this true? What are they doing? They're adding 9 x's up and they're adding 8 y's. Can you find where 9 x's are and 8 y's are in this picture? Now, these are all fences. So this is fence, this is fence, this is fence, this is fence. So maybe that'll help. This looks a little crazy, so don't look at it. Just find the area of each pen. And it's equal to x times y. That's it. Oh, wait a minute. Can you put this in terms of x? Gee, it would be so great if we had an equation that had x and y in it. Oh, we do. Oh, I love this problem. God, love math. All right, check it out. We're dragging point B. We could drag it down here and get a rectangle like that. We could drag it up there and get a rectangle like that. So hopefully you understand the question. We're asking basically, what is it, so that we get an blah blah blah. What is it that we get a rectangle of maximum area? You know, you can put an X there and a Y there. See if you can't figure out in general what the coordinates in terms of X and Y, of course, but try to make this in terms of X. What is a relationship that X and Y have together? Oh man, it might have a lot to do with the 6 and the 8. I'm going to stop there. Good luck, everybody. Those should definitely give you a good challenge. Like I said, this is more of a reference video, so I'm going to put it as a YouTube. And I don't think that's really necessary for you to know at the end of it, so I will stop talking. See you later.